Hello and welcome back to another video from the Luxygen world of billionaires, luxury, and mega projects. In today's video, we will take a deep dive into the ambitious space elevator project and what it will look like if launched by 2045. Imagine moving to Mars, but leaving your prized automobile behind on Earth. Do you know how much it will cost to transport your car to your new home? Almost 40 million bucks. That's because it can only be delivered by a space rocket, and launching it is highly expensive. For example, the Atlas V rocket was launched into orbit for $160 million. However, there is almost no capacity left in the rocket for anything other than the fuel compartments, and cargo space is extremely limited. Scientists have long debated how to replace missiles in order to reduce cargo delivery costs and make space travel accessible to everyone, not only astronauts and millionaires. A space elevator, a structure with a height of over 20,000 miles from Earth that can transport you to orbit, is one solution. Simply press the up button to ascend to the skies, albeit such an elevator will definitely be costly to construct. It will allow for a huge reduction in the cost of launching objects into space, allowing space travel to become an everyday occurrence. In this video, you'll learn how to defy gravity, why the moon is better than the Earth, and how far the space elevator can take us. To circle the world, a body must first resist the planet's gravitational pull and get high enough, and then it must continue rotating at the same speed as the Earth to avoid falling. A rocket is equipped with an engine for this purpose, and the engine's operation is based on a combustion reaction in which the fuel burns. The oxidizer aids in the formation of gas. The gas is let out through the nozzle. However, hundreds of tons of fuel are required to launch the rocket. The high launch cost is due to this. A space elevator could make it easier to defy gravity, obviating the need for the most expensive component. It's straightforward. A base, a cable, a climber, and a counterweight make up the elevator's design. The base is where the cargo is raised, and the cable is attached to the planet's surface, as well as where an elevator operator awaits you. In the climber, he'll be waiting for you. The climber is the elevator's moving portion, which eliminates the need to waste massive amounts of fuel. A space station or an asteroid can be used as a counterweight to launch from the Earth's surface, or any object heavy enough to hold the other end of the cable. The cable is essentially the path that the climber takes from the ground to the sky, from the base to the space station. The most difficult part is deciding which material to utilize. To build a cable, it must be strong enough to endure high winds, harsh temperatures, and radiation, while yet being light enough to make a 20,000-mile-long element. No material currently available, such as graphene, Kevlar, or even the toughest modern carbon fiber polymers, can withstand the load. Failure is not an option when selecting the material. After all, in the best-case scenario, if the cable is severed, it will wrap around the Earth. In the worst-case scenario, it will remain in space indefinitely, destroying everything in its path. Scientists, on the other hand, offer answers to that problem. We can use the moon, but Sefer Fenoyri of the University of Cambridge in the United Kingdom and Emily Sanford of Columbia University in New York proposed building a space station on the moon's surface and then dangling a cable to the ground. Because the moon's gravity is 6 times less and rotates 30 times slower than the Earth's, the elevator structure will be subjected to less strong forces than on Earth. The moon is also substantially closer to the Lagrange point. The Lagrange point is a place in space where the gravitational pull of the Earth and the moon are equal. All objects that are sent there have a tendency to stay put. A stabilizer for the entire structure could be installed there, but even with a stabilizer, the cable from the moon to the Earth will be under a lot of tension, according to Fenoyri and Sanford. However, they claim that the cable does not need to be extended all the way to the Earth's surface. we can reduce the tension by leaving one end of it in the geostationary orbit at a distance of 35,000 kilometers from the surface. It may thus be possible to construct a cable from existing materials. Take, for example, carbon fiber. However, full execution of such ideas would necessitate more testing and billions of dollars if more well-thought-out solutions were available. Skyhook is the name of the solution. A revolving satellite with a long cable on one side and a shorter one with a counterweight on the other is the concept. Skyhook has no foundation and does not stand on the ground. This implies that cargo must be transported there. As a result, the first step in attaching cargo or a satellite to the hook is to get there. Although a launch vehicle will be required to reach the lower end of the hook and attach goods, it will be less expensive than a typical launch. Furthermore, the hook would not only carry goods, but it will accelerate it as well. By revolving around its axis, the hook will literally pick up a spaceship on the edge of entering the planet's atmosphere and launch it into space at incredible speeds, much like a big catapult. There is a danger, though, that space debris will get in the way. Even if we clean up the orbit beforehand, we won't be able to use Skyhook for very long anyway, according to the European Space Agency. There are currently around 2 million objects of various sizes and diameters revolving around the Earth, and because they all move at around 8 kilometers per second, even a small piece of debris can pose a serious threat. It will deorbit and descend down if it is loaded unevenly in order to rotate smoothly. Skyhook must be launched as well as capture fast-moving spaceships at high altitudes. As a result, it will slow them down before allowing them to fly at lower altitudes. There will be no rotational energy loss in setting up such an exchange in such situation. Scientists propose building a new hook on Mars that will allow spaceships to fly between the catapults and allow humans to settle the planet. Even if we figure out a way to compensate for resource limits, the fact remains that Mars has no minerals or nuclear materials, as well as no solar or wind power. We will have to bring too much from Earth, and we might wind up destroying one planet while never conquering the other. We'll need the resources of other planets in that situation, but how will we go around the solar system? We could install skyhooks across the solar system, such as around Mercury, Venus, Earth, Mars, and a massive asteroid belt, to make it easier to take off and land on these celestial bodies. Such a system of space catapults might potentially make resource extraction on the planets cost feasible. A well-organized system of space transportation may help supply everything needed for the colonization process, and the price for 1 foot of a lifted load could reduce from $3,500 to $25. That implies that Earth will not be destroyed, and it will be unnecessary to launch costly and wasteful fuel rockets. Don't assume this is just a fantasy Tokyo-based worldwide building corporation. By 2050, the Kobayashi Corporation plans to construct the world's first space elevator. Beijing increased the stakes by announcing that they will accomplish it 5 years sooner. If it really is going to happen so soon, it's time to start thinking about who will clean up after us, since if anyone wants to go to Mars, there will be more debris in space, and there is currently no cleaning business that can provide outer space cleaning services. What do you think of the space elevator? Do you think it's feasible to have it made by 2045? Do you have other ideas on how we can reach other planets in the galaxy? Please let us know by commenting your ideas down below. Thank you so much for watching this video. We hope you enjoyed it, and we hope that you learned a little bit more about the space elevator and its proposed 2045 launch. Please join us again for another LuxyGen video. To stay updated on our newest videos and content, please hit the like button, smash that notification bell, and subscribe to our channel. We hope to give you more videos in the future. Until then, take care and see you in the next LuxyGen video.